Alright, the next portion is very, very easy. Compared to what we just did, this is a very easy one. Sorry about that. We're going to evaluate each limit, but this time we're going to just do it numerically. So this one you need a calculator for. Right? It should be easy. You should be able to do it without a calculator also. So this portion, we're going to just substitute the value into the function. To substitute 3 in for x. So for like this portion here, we're going to substitute 3 in for x here. You can either put that directly into the calculator, or you can actually work it out by hand. 27 minus 45 plus 21 minus 10 and do it. You can do it by hand too, so it shouldn't take long. You should get a -7 for that. And that's it. That's all she wrote. So the limit of this this polynomial is, as x approaches 3, is -7. Easy, simple. Just substitute it in. All right, this next one is supposed to be pi right here. So again, we're going to substitute pi in for x and solve it out. And so here, we're going to do cosine pi over pi. And again, you're supposed to know your values, your trig values here. So hopefully everybody remembers what cosine pi is without putting it in the calculator. You can just think about it and be like, bam, I got it. So here, hopefully everybody knows that's -1 over pi. -1 over pi. Bam! And you're done. So 9 times out of 10, they'll like for the final exam or something of that sort, they'll have you put in the calculator and get a decimal answer of some sort. But in this case, we're just going to leave it like that. So if you leave it like this on my work, it's okay. It's perfectly fine. You don't have to get a decimal answer for this. All right, so that's example 3. Simple, easy, not hard. Not hard at all. But let's go to example 4 then, because this one has a little bit more work. So this time, and with these two problems that we have, we're going to evaluate it with algebraically. Now, here we have these two functions, or these two limits. One thing I want you to make sure you understand is something that you'll talk about in calculus also. There's a thing called an indeterminate form. Indeterminate form. All this means is when you substitute a value, like for example 4, you substitute that value into the x values and then solve it out. You will either get one of the two things, or one of three things. You'll get 0 over 0, which is an indeterminate form. You can't determine what the answer is. You get positive infinity over positive infinity, or you get negative infinity over negative infinity, which is positive infinity. You'll get, or any form with a positive and negative infinity in it. So it could be any of these types of things. It could still be like a positive infinity over a negative infinity, anything like that. That's all indeterminate because it's either infinities or it's 0 over 0, which is not an answer. So if anything happens like this, where you get 0 over 0, infinity over infinity, negative infinity, any of that, if you get any one of these down here, that means that you have to algebraically work it out. Or in other words, factor. So if you in your calculator go back and put 4 in for x here, put 4 in for x here, and put 4x here, and 4 in for x here, if you work that out, you'll get that that's 0 over 0, an indeterminate form, which we cannot have. So what we're going to have to do is factor our numerator and denominator, if possible, and see if we can get things to cancel out, and then work it out. So in this case, we're going to factor out this first portion, which gives us 2 parentheses. In this case, if you can remember, hopefully you remember how to factor a trinomial down to 2 factors. You should get x minus 4 here and x plus 2 here. So you multiply -4 and +2 is -8. And then -2 and -4 and +2 add together gives you -2. All right, so then we get x, and factor out an x on the bottom, we get x minus 4. And we should be able to get those two things to cancel out right here, the x minus 4s, because one's on top, one's on bottom, we're multiplying. So really what we're going to deal with here for our limit is we're going to find the limits of x plus 2 over x as x approaches 4. So we're going to substitute 4 in for x here and get an answer. And so here I'm going to do that really quick. And so here we get 6 over 4, which reduces down to 3 over 2. And we're going to keep 3 over 2 as your answer. So pretty much all we're doing is just factoring. So if you can factor it down, you should be able to be good. If you remember how to factor, you should be good. Right, the other one is this portion here. And again, we're going to factor it down because if you substitute 0 in for each one of these, again, we're going to get 0 over 0, which is our indeterminate form, which we don't need, which we can't have. So we have to factor again to try to get something to cancel out. So here we're going to factor out an h because they all have an h on top. We're going to factor out the h. Okay. And then we should be able to get an h to cancel out. So this h and this h cancels out. So again, our whole thing now would be the limit of h squared minus 4h minus 6 as h approaches 0. And again, we're going to substitute 0 into the problem, and we should be able to get an answer. We should be able to get an answer real quick here. So we substitute 0 in for that one, substitute 0 in for this one. So our final answer would just be -6. And that's it. That's the answer to your limit function, a limit problem. All right, so then now we're going to go to our next example on that next part of notes. And really, I think we only have one more example left, and then we are done. All right, see you then.